Welcome to Brain Vision.
So here in this problem we are given this car that has a mass of 25 megagram and is moving at a constant speed of 1.2 meter per second under a hopper which releases coal into the moving car at a constant rate. M dot is 4 megagram per second. So at this rate the coal is being entered to the car. Now we have to determine the distance traveled by the car during the time that 32 megagram of coal is deposited in the car. So mass that is deposited in the car, that should be deposited in the car, is 32 megagram. So this is what we are given in the question, and we have to calculate the distance traveled during this time period. So for that, to solve this problem, we'll be using Newton's second law of motion, and this one will be considering our x direction. So we can say that sigma fx will be equals to d over dt mv. This is the Newton's second law of motion, and since there is no force is acting on the body, since the car is moving at a constant velocity, so net force acting on the body should be 0. So we can write that this is 0 is equals to d over dt. Now as the car is moving to the right side, the mass of the car is increasing, and which is function of time. So that mass can be written as m naught, this is the initial mass, or basically the empty mass of the car, plus m dot times t, and as the time is increasing, the mass of the car is increasing, times v, as it is. Now we can differentiate this, so we'll get 0 is equals to m naught plus m dot t, and dv over dt is acceleration, plus m dot v. We have just used chain rule here to differentiate this function. Now from here the expression for acceleration comes out to be as minus m dot v divided by m naught plus m dot t. So this is the expression for acceleration. Now we know that acceleration is equals to dv over dt. The rate of change of velocity is known as acceleration. So this equation would become, this would become dv over dt is equals to, this would minus m dot v divided by m naught plus m dot t. Now we can do one thing, we can take v to the left side and t to the right side. So this would become dv over v is equals to negative as it is m dot divided by m naught plus m dot times t, and this is dt. Now we can integrate both the side, and when the time is 0, the velocity is v naught, that is 1.2 meter per second. Now when the time becomes t, the velocity is v. Now we're going to integrate both the sides. Get natural log v, and the limit is v naught to v is equals to, and here we'll get negative as it is natural log m naught plus m dot times t, and the limit is from 0 to t. Now we can put the limits, and after putting the limits we'll get the expression for v to be m naught times v naught divided by m naught plus m dot t. So this is the expression for velocity. Now velocity can be written as dx by dt. The rate of change of displacement is nothing but the velocity. So this can be written as dx over dt, and it will be equals to, this is as it is m naught v naught divided by m naught plus m dot t, and we can rewrite this thing as dx is equals to m naught v naught divided by m naught plus m dot t dt. Now again we can integrate both the sides. So integration, integration. Now when the time is 0, the distance traveled is 0, and when the time t becomes small t, the distance traveled would be x. Now again let us integrate this integration. So here we'll get x is equals to, and after integrating the right side we'll get m naught v naught divided by m dot times natural log m naught plus m dot times t divided by m naught. So this is the expression for the distance x that we have to calculate. Now, but here we have all the things, but we don't have the value of t, and this t is basically the time required to deposit coal of 32 megagram. So time t would be equals to the mass that should be deposited is 32 megagram, and the rate by which the coal is being deposited is 4 megagram per second. So divide by 4 megagram per second. So we'll get this value to be 8 seconds. So this is the value of t. We can plug it here to calculate the distance traveled by the car in this time period. So x would be equals to m dot, we have this 25 megagram, we'll convert into kg, times 10 to the power 3 kg. V naught is basically the initial velocity, which is 1.2, divided by m dot is 32. Again we have to convert the units, 10 to the power 3, times natural log, this one is 25 times 10 to the power 3, and then plus m dot is 4 times 10 to the power 3 multiplied with 8. M dot is 25 times 10 to the power 3. So we're going to solve this for x, and we'll get the value of x to be nearly 6.18 meter. So this is the distance traveled by the car during the time 8 seconds, and in this time period 32 megagram of the coal would be deposited in the car. So this was the solution for the given problem. I hope you have understood the problem. Thank you.